work on doing exponents and radicals. Okay, so the first thing we're going to talk about is multiplying powers. So this is kind of hard to explain, so we're just going to start off with an example problem. So when you're multiplying powers, what you can do is add them together. The important thing to remember about this is that you need to have the same base number before you decide that you can multiply these together. So in this example, you see that we have 4 to the power of -3, and we have 4 to the power of 5. And we want to multiply these two numbers together. So what we're going to do is add the exponents and keep the base the same. So the key here is that the base does have to stay the same. And it has to be the same for the two numbers that you want to multiply, otherwise you can't use this like little shortcut trick. Okay, so since we do have the same base, what we can do is add these together. So on the left side, we have -3 as the exponent, and on the right side, we have 5 as the exponent. So what we want to do to simplify that is just add the two exponents together. So when you want to multiply 4 to the -3 times 4 to the 5th, you can just get 4 to the -3 plus 5. And remember your PEMDAS rules, you always want to solve your parentheses first. So here, when you have -3 plus 5, you get 2. So once you simplify this here, you get 4 squared. Okay? Now you can simplify this further. 4 squared is 16, but when you get to higher exponents, and if you don't have calculators, it sometimes gets a bit difficult. So for now, we can leave it in this form, but you're definitely welcome to simplify it if you would like. Okay, so now we can talk about how to check our answer and how we know that this shortcut works. Okay, so one important thing to know is that when we have a negative exponent and we want to get it to become a positive exponent, just so that it's easier to work with, because we generally like working with positive numbers over working with negative numbers, we just find the reciprocal of this exponent. So a reciprocal basically means when you have a fraction, you just flip it. So if you have 4 to the -3rd, it's actually implied that there's a 1 under it, because if you divide it by anything by 1, you just get itself, right? So what we imply here is that 4 to the -3rd is equal to 4 to the -3rd over 1. Now, if we want to flip that, you would just get 1 over 4 to the -3rd. Now, since we flipped it, this negative exponent right here becomes a positive because you're putting it in the denominator. So that's how we get this equation here, that 4 to the -3rd equals 1 over 4 to the 3rd. Okay, so now we can check our multiplication. So here in green, I highlighted 4 to the -3rd. Sorry, one second. Okay, so here I highlighted 4 to the -3rd, and that's in green here. So remember how I said you can flip it and you get the reciprocal, and then it's a positive exponent. That's what I wrote out here. So 4 to the -3rd equals 1 over 4 to the 3rd. Now we can just expand our 4 to the 3rd, multiply it out, and you get 4 times 4 times 4, because what is 4 to the 3rd? Multiplying 4 by itself 3 times, right? And in purple here, we have 4 to the 5th. Now when we write that out, we get 4 times 4 times 4 times 4 times 4. Now, since I mentioned there is no denominator, it's assumed that the denominator is 1. So technically, this purple section right here is the numerator, and all of this is divided by 1. The only thing is that doesn't make a difference because they're equal, and it's just easier to write numbers like this. So since we are multiplying and dividing here, we can cancel out numbers, because what we have in the numerator is the same as what we have in the denominator to a certain extent. So in this example, you have 3 4s in the denominator and 5 4s in the numerator. So what happens is, since there's more than 3 in the numerator, 3 of these 4s cancel out with these 3 4s. Okay, so what you're left with are these 4s, these 2 4s right here, and if you bring them down, this is what you end up with. And then if you simplify that, that's 4 squared, because 4 times 4 is 4 squared. Now, if we look back up here, that's what we got. Okay, so we went through that whole process to check our answer. Now, if you really, really wanted to, you could multiply powers with the same base this super long way if you wanted to. But it is really long. And so using this shortcut is something that is super helpful, especially when you get into harder math. And so that's why we use it and that's why we teach it. Okay, are there any questions on how multiplying powers works? Okay, so then we're gonna do 2 practice ones. So I want you guys to simplify these and figure out what it would be. If it's a really high power, you don't have to multiply it out. You can just leave it like in this form, like 4 squared. Or if it's like 9 squared, then you can leave it in 9 squared if that's if you don't have a calculator. Otherwise, you can multiply it out. Either way is fine. But I want you guys to try these. I'll give you a couple of minutes and I'll leave this example up too.
I can't write powers. Wait, do you use that like little up arrow thingy?
Yeah, you can use
Wait, I think you can like use control. Wait, it depends on if you're on different things. If you're on like Windows, then I think you use control and dot.
if you guys have paper, then it's easy to write down. So maybe you can go grab that, or you can use the little up arrow sign. That's fine. Oh, you mean to type in the chat? Yeah, use the up arrow. It's if you have number 6 and then it's like a little caret, and that's how you can write it in there. And make sure you're sending these directly to me so that everybody else has a chance to work on them. Okay, 1 more minute. You guys are doing really good on this. Okay, does anybody want to explain how they did number 1? Apollo, go ahead.
So for number 1, if the first number is the same, which is 9, then you just add the exponents together. So negative 3 plus 12 is 9, so it's 9 to the power of 9.
Yep.
Can I do the second one?
Yeah, I don't know who that was, but go ahead. After I write this down.
So I can't see the other problem.
Yeah, let me write this down for those of you guys who were a little bit confused because I had a couple questions. Oh my gosh. What is happening? Okay, I'm gonna unshare my screen and share it again because this is really glitchy. Sorry, 1 second. Okay. Okay, yes, go ahead.
So since both are the same, 8, so you add 6 plus 8, and 6 plus 8 equals 14, so it's 8 to the power of 14.
Awesome. I really like how you mentioned that the base is the same and the base is both 8, which is a really important thing to remember. And I'm really glad you said that. So that is something that you always need to make sure is true before you use this trick of adding the exponents. Okay? So now we're going to move on to dividing powers. So when we're dividing powers, we subtract the exponent. Remember when we did multiplying, we just added the exponent. So similar to multiplying the powers, when you're dividing the powers, you just subtract the exponents. Again, really important to remember that the base that you have is the same. It's always really important to recognize that. Otherwise, the trick that you're trying to use will not work and you will get the wrong answer if your base is not the same. Okay, so let's go through an example really quickly. We have our base of 12 here, and we check that they're both 12. And then in the numerator, the exponent is -7, and in the denominator, the exponent is -5. So what we do is subtract them. What I like to do is write it out so that it's easier for me to see, but if you could do it in your head, totally fine. So we're doing -7 minus -5. And so since we're doing two negatives become a positive. So you end up having -7 plus 5. And that is -2, which you see right here. So you have 12 to the -2. Okay? So as I mentioned earlier, when you have a negative exponent, you can rewrite it to have 1 over the base to the positive exponent. So we have 12 to the -2. So you're going to do 1 over the base, which was 12, to the positive exponent, which is 2. Okay? So when we do this, we have 1 over 12 squared, which is right here, and that's our answer. Now quickly go through how you can check this one. So we use our reciprocal rule again. So 12 to the -7 is 1 over 12 to the 7 because we have our base 12 and our exponent is -7. You do 1 over base, which is 12, and positive exponent, which is 7. And then in the denominator, since we have 12 to the -5th, you do the reciprocal of that to find the positive exponent. So since 12 to the -5th is in the denominator and right here, to get the positive one, we would flip it over again. And this is basically 12 to the 5th over 1, because if you just flip these, then that's what you get. But we don't write the 1 over it because it's kind of just implied, because if you divide anything by 1, you have itself. Okay, so I highlighted those here. So the green is a 12 to the -7. So 1 over 12 times 12 times 12 times 12 times 12 times 12 times 12. I think that was 7. And then the purple is here. Remember the reciprocal rule, we flipped it. So it's 12 to the 5th in the numerator. Remember, this is all basically over 1. Okay, so we have 5 12s in the numerator. And then we can use our canceling rule because this is multiplying and dividing. Remember that you can't use this canceling out process when it's addition and multiplication, or addition and subtraction. You can only use it when it's multiplication and division. So we do that, we cross out 5 12s here, and we cross out 5 12s here. So we're left with these two 12s in the denominator. That's what we have, 1 over 12 times 12, which is 1 over 12 squared. Now, if we look back up here, that's exactly what we got. Okay, so again, if you really feel the need to do it the long way, go ahead. It's just, we do this shortcut so that when you get into higher math and more difficult math, it makes it a little bit easier, and it's really helpful and it works. just make sure, like I said before, make sure you have the same base when you're multiplying or the same base when you're dividing so that you can use the shortcut. Okay, any questions? Okay, so yep, we're gonna do some practice. 2 of these and then we will go over them. Oh yeah, you guys can put your answers in the chat directly to me, not to everyone, so that everybody has a chance to try it. About 1 more minute, guys. Okay, does anybody want to explain how they did the first one?
Can I?
Apollo, go ahead.
Okay, so since it's divided, you subtract the exponent. So it's -3 minus 12, which is -15. So it'd be 9 to the power of -15.
Yeah, that's correct. Another way to write
Wait,
that.
is it 1 over 9 to the power of 15?
Yeah, good job. Technically either way is correct. I just like working with positive exponents, but depending on what you're doing with them, you'll need to switch between the two forms, which is why it's important to know both of them. Good job. Yeah. Okay. Anybody want to do the second one?
Can I?
Yeah, go ahead. I don't know who that was, but go ahead.
Since 8 have the same base, so you minus 8 minus 6, so the answer is 2, so it's 8 to the power 2.
Good job. Yes, that's correct. One thing I wanted to address, because a couple of you guys were doing this, and it's a really common mistake, so don't be like worried about it or anything. But some of you were adding them and flipping it because you thought that when you're dividing them, you want to add and flip them. So a bunch of you were getting, in this one, you were getting 1/9 to the 9th, which is what you would do if you did -3 plus 12 and then found the reciprocal, which is not what we want to do. We want to subtract the exponents. And the only reason we would flip it is if we wanted to go from a negative exponent to a positive exponent, or positive exponent to a negative exponent. So the only thing that flipping or flipping the fraction or finding the reciprocal would do is change the sign of the exponent and put a 1 over it or divide by 1. So make sure that when you're dividing, you are subtracting the exponents, not just adding them and flipping them. Okay? Cool. Okay, so now we're going to talk about powers of products. I know it sounds really confusing, but basically, powers of products just means that if you have a number and it's raised to a number, and that's raised to another number, what you can do is multiply these two numbers together. Okay, so maybe that doesn't make sense in words, so let's look at an example. Let's say here you have 4 to the power of 2 to the power of 2. What you would do here is multiply the exponents together. So 2 times 2 is 4, right? So what you would do is multiply those two together, and then you would have 4 to the power of 4. So you could just multiply the exponents together and leave the base the same, and then once you do that, you have a new equation and you can solve it. I know this one is a bit difficult to do without a calculator, so you can leave it in this 4 to the 4 form, or you can simplify it and you would get 256. Okay, let's look at another example really quick, just because that might be a bit confusing. So we have 2. Did you have a question? No? Okay, sorry. I didn't have a question. So we have 2 to the power of 3 to the power of 2. How to solve this? You would multiply the two exponents together. So you'd multiply this times this, and you get 6, which is how you get 2 to the power of 6 right here. Okay? And that's 64. But of course, you can just leave it in the 2 to the power of 6 if it's a bit difficult, you don't have access to a calculator, whatever the issue might be. Okay? Any questions on those, because it does get a bit more difficult than that?
Do we have to simplify it?
No, you don't have to simplify.
64, 256.
Yeah, that's okay. You don't have to know that. I just wrote that down in case some of you guys were using a calculator.
A long time to do that.
Yeah, it would take a long time to do that. I definitely had to use a calculator for that one too. Okay, so it does get a bit more difficult than that, okay? So when you have a problem that looks like this, the first thing that you want to do is separate them. So what you're going to do is apply the very outside exponent, in this case it's the -2. You're going to apply that to the inside exponents while you separate the numbers and separate them while you separate the numbers and put parentheses around them. Okay, so with this example, you see that you're multiplying 3 to the negative 8th times 7 to the 3rd. Okay, so what you're going to do is separate those two things that you're trying to multiply and bring the negative 2 exponent with them. So you can separate, you can separate them into 3 to the negative 8th to the negative 2 multiplied by 7 to the 3rd to the negative 2. Okay? Any questions so far on that? Okay.
Do you have
Now,
to put it in the fraction form?
actually, I would not put it in the fraction form just yet because it's easier to deal with multiplying exponents when they're not in the fraction form. Okay, so I would go through all the multiplication and then decide if you want to need to put it in the fraction form. Okay, so now these each separately look like the problems we just did up here, right? So what you can do with this one is multiply these two exponents. So you have negative 8 times negative 2. When you multiply those together, you get 16, right? So this section right here just becomes 3 to the 16th. Now right here, you multiply these two exponents together, 3 times negative 2. And when you do that, you get negative 6. So that would be 7 to the negative 6. Okay, now here.
How do you put like division in the chat? It's kind of weird.
How do you put
Just
division?
put it like a fraction sign.
Yeah, use the backslash, the fraction sign.
Okay.
Yeah, okay.
It's easier to like put the 3 to the power 16 times 7 to the power negative 6.
Yes. Yeah, it is. But sometimes it's easier to deal with, oh, this should be positive actually. It's easier to deal with positive exponents, which is why I like to do it, but you can definitely leave it in this form here. But since you have this negative exponent, adding or finding the reciprocal of it would just be 1 over 7 to the 6th. And then when you multiply that by 3 to the 16th, you get this right here. Okay, so that's why I just like using positive exponents, but this right here is also a valid answer. Okay, any questions on that? Okay, I know it was a bit tricky, so I'll leave it up while you guys are doing your practice. So that's your practice problem, and I'll give you guys a couple minutes to do it.
For the times, do you just add an X, like add in capital X?
For showing the multiplication symbol?
Yeah.
Yeah, you could do that, or you could put this little dot like I put right here, or you can draw parentheses.
In the chat, you can't really do that.
Oh,
It's on
sorry.
the bottom.
Yeah, do a lowercase x since we're not dealing with variables today. You can just use a
Okay.
lowercase x for a multiplication sign. one more minute. Okay, does anyone want to go through their process of how they did this one?
Can I do
Who was that?
it? Athena?
Okay, go ahead, Athena.
Okay, so 3 to the power of 3. Well, basically, so 3 times negative 3 equals 9. Since there's a negative and there isn't two negatives, it would be a negative. So it'd be 3 to the 9th. And then 6 times 3 equals 18. There's a negative. So it would be 6 to the 18th.
6 to the negative 8.
Negative 18th, I mean. Like other negative.
Does anyone want to, who simplified it, want to know how, or want to explain how they simplified it?
Can I?
Yeah, go ahead.
So since it's 3 to the power of negative 9, wait, so wait, no, since it's 3 to the power of negative 9, you'd add a 1, so it'd be like 1 divided by 3 to the power, wait, yeah, 3, so 1 divided by 3 to the power of 9 times 6 to the power of 18.
Yep. And then what you can do is just combine them over 1, and you get 1 over 3 to the 9th times 6 to the 18th. If you had this answer, that is correct. If you had this answer, that is also correct. Okay, so there are 2 correct answers. Just depends what you prefer, depends what you want to do. Okay, any questions on that? Anyone need me to go through it again? Okay, then we're gonna move on. We're gonna talk about square roots now. So now we're on to the radicals part of exponents and radicals. So that was the radicals part, that was the exponents part, and now we're on the radicals part. Okay, so right here is a symbol for a square root. Okay, so how to teach square roots is first by teaching squares. Okay, so we know that 3 squared is 9, right? So to find the square root of 9, it's 3. So basically, what squared is 9 is your answer to the square root of 9. So if you think about what squared is 9, you know that it's 3. So if you're asked, what is the square root of 9? You just think, what squared is 9? And you know it's 3. Okay? So basically how square roots work are they are the opposite of squares. So if we look down here, we know that 4 squared is 16. So the square root of 16 would be 4. So to solve it, think, what squared is 16? Well, 4 squared is 16. So the square root of 16 is 4. Okay?
Could there be like, for example, a 3? Square root of 3?
Yeah, actually, we're going to get into that.
1.5?
Like square root of 3 is,
I don't think that's like I think, is that repeating or something?
It is repeating. That's correct. It's a bit difficult to do, and you're probably not going to be asked to do it in your head. But if you really want to know, I think that the square root of 3 is like 2 point something, maybe.
But on questions, if they tell you to do stuff like the square root of 3, you can just round it, I think.
Yeah. Yeah. The square root of 3 is like 1.73. Yeah. But you will never be asked to do that in your head. I promise. I have never been asked to do that in my head. But it is possible, and the square root of 3 does exist. So, yeah, so back to like a simpler number. 5 squared is 25, so the square root of 25 would be 5. Okay, this probably isn't too difficult, should make sense. But another thing that you need to know and remember is that when you square a negative number, you get a positive number. So when you square -3, you get +9. So when you square -3, you get 9. And when you square +3, you get 9. So basically, what you learn from this is that each square has 2 square roots. So up here, I told you that the square root of 9 was 3. Down here, I'm telling you that the square root of 9 can be 3 or -3. Does that make sense? Because when you square -3,
There are two
Okay.
negatives and it becomes.
exactly. When you square -3, you're multiplying -3 times -3, and 2 negatives become a positive. So you get the same answer as if you were multiplying +3 times +3. So now when you ask yourself, well, what squared is 9? You know that, well,
3 or
3 squared is
-3.
9. Yeah, but -3 squared is also 9.
So you don't know what they're asking for. So you could
Yeah.
get one right or wrong.
Yeah,
if you're
so
on a test.
if they don't specify if they want a positive number or a negative number, if you put either answer down, it should be correct, and they will count it correct. Okay, so similarly with 16, well, what squared is 16? 4 squared is 16 and -4 squared is 16. So the square root of 16 is 4.
And then
or
5
negative-
and -5.
Yeah, so with 25, the square root of 25 is 5 or -5. Okay, so I want you guys to do
About 2.
what?
2. Does 2
2?
have a
What's
square root?
That's what I think she's asking what's the square root of 2.
I'm not at, oh, you want to know? Let's see if I can
Wait,
remember.
no, I think she was asking about square root of 2, or is it the practice problem 2?
I'm not going to make you find the square root of 2. The square root of 2 is also a decimal number, but I think it's like 1.4. 1.41 is the square root of 2.
Is it repeating?
It's not repeating actually.
Really?
Yeah.
Do
I
you
don't
want these positive or negative?
If you are ever asked to find, or if you are ever doing a math problem and the answer that you get is square root 2, you can leave it as square root 2. You will never be required to simplify it. So don't be worried about that. You'll only be required to simplify perfect squares. That's what these are called. When whole numbers are squared, you get a perfect square. Okay, so try these 3 and we'll come back super quick. And
Positive or negative?
thank you for asking. Good job.
Anyone?
You can put either one. I'm okay with that, or you can put both. Either one is fine. Just make sure you're aware that there are 2 answers to each of these 3 problems. I'll give you like 2 minutes. Yeah, the last one's kind of a big number. So if you need to use a calculator for that one, that's fine.
I think the easiest way is just remember to your multiplication table up to 12.
Yeah.
Yeah, that actually helps a lot. If you are ever like forced to learn the multiplication table, definitely learn it. It really helps. And even when you learn like the highest level of math, I promise the multiplication tables will come in handy. Yeah, you guys are doing very well on these. Mhm.
So then you could just bring a multiplication table all the way there when you're in really good math. You don't really have to memorize them.
Yeah.
You don't write a multiplication table. I'd be like, take too long to like
Just
look
buy
for it.
one. Just buy one.
Why? If you can just remember it. But just
Okay.
memorize it.
It's easier.
Okay, we're gonna go over these. Does anyone want to say their answers? Someone who hasn't said them.
Why?
Let's see if anyone else wants to. You guys can say in the chat too if you want. I know a lot of you guys are getting these right. Okay. Yeah, Athena, go ahead. You can explain or just tell me your answer. I don't know how to
Okay,
explain.
so 7 times 7 equals 49. So the square root of 49 is 7.
Does anyone want to say the other answer to this problem?
-7.
Yes, good job. Okay, this one,
Can I do it?
no.
Okay.
Yeah, Apollo, go ahead.
Can I do it?
Yeah, who
Wait,
is
wait,
that?
wait. They
Wait,
can do
who
it
is-
instead.
No, wait. Who is that?
Me, Justin.
Yes, go ahead.
Okay, so 6 times 6 is 36, so the square root of 36 is 6 and -6.
Awesome.
Can I do number 3?
Who was that?
Tina again. Can I do number 3?
Yeah, Apollo, go ahead. Athena, you did the first one.
Since 11 times 11 is 121, the square root of 121 would be 11.
And
Or -11.
awesome. You guys are so good at this. Okay, we're gonna play Kahoot.
Yay!
Unless you guys want to learn about cube roots.
About what?
Cube roots.
Cube roots.
Okay.
Cubes?
Cube roots. So like
I guess it's like 3 to the power of 3, basically, or 4
anything to the
three.
power of 3.
Oh, that's what I meant by cubes.
Yep.
I used to thought cubes were 2.
Okay. Play. Okay. Can you guys hear it? Oh wait, it didn't start yet. Okay, can you guys hear it?
Yes.
Awesome. Okay. We don't have that much time left, so we're gonna start pretty soon. So make sure you get your name and if you want to play. This is about exponents, okay? So the first part of what we learned.
Only 3 people
I know.
will be the
That
top
is
3.
That's one way to get top 3.
Yeah.
True. You don't have to put your real name if you don't.
I remember once I played a Kahoot, there were only like 5 people, so it was like super easy.
Oh my gosh. Yeah.
Yeah. So you'd always fit like top 5.
Yeah. I'm gonna wait like 1 more minute and then we're gonna start because this has 9 questions, I think. And I want to. That's a lot of tabs. Yeah, sorry. Yeah, I do have a lot of tabs.
Can we start now?
Yeah, like 20 more seconds. Count to 20. Guys, come on, join.
I counted to 20.
Okay, now we're starting. Yay, exponents. Okay,
How many people are playing?
9, I think.
8.
8. Oh yes, you guys are so good. Okay. Whoever is me, great. You're winning.
It's easy. You just memorize which one's true and which one's false.
Yeah, that's
Yeah,
so
but what you could do next time is switch it.
I actually
don't think you
did that
can.
last time.
You can.
Yeah, you can. Yay!
Wow.
Awesome. Ooh, Athena. Okay.
That one's confusing.
Mm-hmm. Yep. Okay. Fork has a streak with 4 correct answers in a row. I don't know who Fork is, but yeah. Oh yeah, this can take a while to read the words.
Not really.
Not really.
Not really.
There is no mistake. That'd be kind of like.
A mistake? Maybe, I don't know.
Because it's asking what is a mistake very clearly.
Yeah.
Good job. Okay, 3 more. This one's a bit hard, actually.
You have to actually do math.
Yeah,
I actually memorized some of them.
you did. That's actually very good. Awesome. You guys are very smart. Okay. Almost done. This is kind of a trick question, I guess. Yeah, okay. So let me just talk about this one really quick. So 1 to the power of 8 is 1 times 1 times 1 and so on 8 times. So when you do that, you would just get 1. 2 to the power of 4 is 2 times 2 times 2 times 2. And when you do that, you get 2 times 2, 4, 8, 16. Okay, so that's not 8. 2 to the power of 3 is 2 times 2 times 2, which is 8. And 4 to the power of 2 is 4 times 4, which is 16. So make sure you're just not multiplying the numbers. Make sure you're seeing the numbers as exponents. Okay?
I forgot that 2 to 3 was 8.
That's okay. Okay. Count carefully.
Well, I can count fast.
Good job, guys. Ooh, who's gonna win? Yeah, this one's hard. This one's a challenge one. I'm gonna see if you guys know this, and I'll explain after. Yep. Okay. Yes. Very good. 3
Wait, did
people.
you go over this?
I did not go over this.
I
That's-
forgot.
Okay, knowledge saved me.
Yeah. Okay. So
At least I'm still on the podium.
when you raise anything to the power of 0, I'm gonna talk about this for 2 minutes, and then you guys are done. Okay. When you raise anything to the power of 0, you get 1. Okay. So 2 to the power of 0 is 1. 3 to the power of 0 is 1. 8,742 to the power of 0 is 1. Okay, I actually don't know why. I will try to find a video. I know there's a good video about it, and I've watched it, so I'll link that. Dimple, do you have a question?
No, I was just about to say that it's 1 because suppose you had like 3 to the 0, you just keep dividing by 3 each time.
Oh yeah, there you go. Yeah, so it's always 1. I know a lot of you picked 0, and that's a very like clever answer. But anything raised to the 0 is 1. Okay, so it's just something that's
But that's when it was.
yeah, it's okay. I didn't teach you guys, so I didn't expect you to know. I just wanted to see. Okay. Let's see. Yay!
Yay.
Yay! Yay!
And then 9 out of 9.
Who was 4th?